Hey, it's your boy Chili here. Welcome back to C++Asio. In the last video, we set up our project. We pulled in Boost.Asio and friends and built it all up. We wrapped it up in our nice little header for a nice clean compilation. And we are now ready to code up a little HTTP client. Just to start off, we're going to work in synchronous mode. We're just going to keep it simple, try to make a client that can hopefully download a file from an HTTP server. We're not trying to make a perfect implementation of the HTTP protocol here. It probably won't work with all servers, but we should be able to get some results and it'll be good enough for us. All right, start with a couple of namespaces here. Namespace as is equal to Boost.Asio. And let's do namespace URL is equal to Boost URLs. Is that not one in here? Ah, because we didn't include it. That's right. Okay, I think we can just include that directly. We don't need to wrap it or anything. Include Boost URL.hpp. That should be fine. So there's a bunch of pieces to the puzzle here, a bunch of components. I'm going to be creating them here. I'll describe them a little bit, but some of them we might have to come back to later on to discuss more in detail what they do. So let's create a URL and we'll call it URL. There we go. URL. I love it. I love that. I love that for you. And we're just going to hard code it in here. I'll put it in the CLI a little later. But just for now, let's hard code that one. And that should pull in that text, should parse it into all the different pieces that we are going to need later on, probably. Now, the other thing that we're going to need right away is ASIO SSL context. And this is the thing that's going to be doing all the magic of, the SSL encryption channel handling. You can just think of it as like a little filter, an adapter you place onto your socket so that it can do that secure transmission for you. And when you construct this, you got to give it. Now it's telling me, IntelliSys is telling me, I don't know what the hell you're talking about. And that's probably a good sign that you forgot to include something. Like, for example, maybe OpenSSL. What about what's in here? Now, we don't actually have to include OpenSSL directly. Boost finds it internally and uses it, but we have to include Boost.Asio SSL.hpp. There we go. And now we should have our SSL context. Beautiful. So we have our SSL context. Now the next bad boy that we're going to put in here is the IO context. Now this is a very important, probably the most important object that you're going to work with in ASIO. It is the arbiter, the master orchestrator of all these operations that we're going to be working with. I am going to be talking a little bit more about how the concept of how a thing like this works and what are its responsibilities. But for now, just know that we need this whenever we're working with something that has to do asynchronous operations, like a socket. When we create a socket, we have to give it the context that it runs on, and we have to submit tasks to the context to get them to start running. Now, let's talk about what we need to do. What are the steps that we have to take in order to, do the operation, to download the file over HTTP? Well, we have a URL. First, we have to resolve that URL to an endpoint. Because TCP/IP doesn't care about your URLs. It says, give me an IP address, give me a port, give me something concrete, give me numbers. I want numbers. So let's do using ASIO IP, Internet Protocol, TCP. So we'll use this namespace. It'll make life a little easier for us, maybe. And we'll create a TCP resolver that is going to resolve URLs to endpoints. And like I said, any component that you have that's going to be doing these asynchronous operations, it's going to want a reference to your IO context. So there you go. We've got our resolver. Now we need a socket that we're going to use for that connection. It represents the connection to the remote server. But we don't need just any socket. So we need a socket that is working with SSL. So we're going to create an SSL stream that is templated on TCP socket. So it's a TCP socket wrapped in an SSL adapter. Obviously, if you're making like a very simple, chat program, hello world kind of sockets program for your baby's first sockets, you wouldn't need to do this SSL stuff. You could just use a TCP socket directly, but we want to do something fun. So as you would expect, you need an IO context. You also need to tell it, unsurprisingly, the SSL context, because it's an SSL stream. So it needs both those things. It needs this IO context and it needs the SSL context that it's going to use to do its magic. All right, let's get to business. So the first thing that we want to do is try to resolve the URL, get the IP address for the URL. So we can use Boost.URL to parse this thing into the host and the path, and we are going to use the host here. So we do resolver.resolve, and we got to give it a query. So that's TCP resolver query. So what is a query built on? So we got a version here that takes the host name, which we have, and takes the service, which is going to be HTTPS. And also takes flags, but I think we can ignore those for whatever reason. Don't ask me why. So we do server and HTTPS. And then we resolve that. Now that is going to get us, that returns something called a basic resolver results, which is a list of endpoint entries. So for one DNS, you could possibly get multiple endpoints, but we don't really care about that. Now let me see if I can do anything with endpoints. So it looks like a range. We can use a range-based for loop on that. And what is this? Endpoint, host name, endpoint. Okay, that's a function, dot, address. So that returns a TCP IP address. There we go, toString. That's nice. So let's just loop over all the endpoints that we get. So we're done here. When it unblocks, we can say, hey, we resolved the URL and print out the endpoints. Now there might be an error that happens here. And the beauty is we don't have to check every single, return call to see if there's an error, check all the error codes. We can just do one try catch on the whole damn thing. So let's just catch anything that's inherited from state exception, output that information, otherwise we return 0. Okay, so let's see if this works. All right, so apparently we can't convert directly from a string literal into URL, but that's fine. We'll do URL view, create a URL view of this string, and then we'll copy that into URL. Technically, we don't even need SSL context. And we don't need the socket yet because we're not using it. So let's just remove it at this point. All right, so that's all that handled. Let's see if this builds. All right, it builds. There's a few warnings in here, but we could probably settle that by perhaps wrapping URL as well, but we won't worry about it right now. Let's run it. And there we go. We resolved the URL to this IP address, which is apparently the IP address of www.boost.org. So, very nice. First problem solved. All right, so the next step is we want to actually connect to that server now that we have the endpoint resolved. So, again, we have to include, I removed it previously, but let's put it back. Boost.Asio SSL.hpp. All right, so now we have access to the secure socket layer, or whatever that's called. So let's create our SSL context, and then we will create our socket, stream socket. Now, a lot of the Boost things that you do, the ASIO things, have free functions. So let's see if there's a connect free function. There is a connect free function. We need a socket, and we need an endpoint to connect to. So the socket is going to be our socket. But the interesting thing is this is socket wrapped in an SSL thing. So we actually want to go socket.lowest layer to get at the underlying TCP socket. I think that's what we want to do. And then we add endpoints in here. And I think Bob's your uncle there. Is there any return from this? That just tells us which endpoint we connected to, I guess, if we give it a list of endpoints. So this should mean that we have connected. Now we're seeing a little bit of pushback from the linker saying, hey, I don't know what all this SSL stuff is, but I can't find it. I only see the declarations, don't see no definitions, bruh. And that's probably due to separate compilations. So what I'm guessing we need here is we need to include an impul for the SSL stuff. So if we look at SSL and we look, see, yeah, they have an impul, and let's see if they have a source. Yeah, they do have a source.http. So this might fix it. I do not recall seeing this in the guide for the separate compilation, but maybe I just missed it. And there you go. No more errors. Of course, you get your standard boost warnings, but here we go. Let's see if we can connect to the server. Resolved and connected to server. Very cool. Now, what if we were to change this from Boost.org to boot69420.org? Is that a real URL? I don't think so. Let's try it out. So we get an exception thrown. No such host is known. System 11001. Yeah. Okay. So that's just our try-catch failing on this call. That's beautiful, and it tells us what went wrong. Now, let's restore Boost.org. Now, the next thing you need to do is you need to do a little handshake, a little shaky. So let's see if there's handshake. No, there is no free function that I can see for handshake. So that's fine. Let's go for our socket dot handshake, and we need a handshake type. So for ASIO, we need SSL handshake. We have a stream SSL stream object. So we use stream-based client because we are connecting as the client. And there you go. Now if we fail the handshake, it should throw an exception, but if we don't, then we say handshake successful. Yeah, we can successfully shake hands. Very nice. Perhaps next we'll learn how to roll over and play dead. So what we need to do now is to make an HTTP request to the server. Say, hey, give us file please. So let's make a string, which is going to be the request. So it'll include string stream, and we're going to make an output string stream in here to build up the request. And that is gonna look something like this. So it's a GET request. We give it the path that we had, I think we parsed that earlier, yep. And we give it the server name, protocol version, what we accept anything, and when we're done, we want to close the connection. And all the new lines and carriage returns that you could possibly ever want. And so let's set our request equal to request stream. Why isn't it auto completion give me this? Request stream dot string. Okay, there you go. So here's our request. Now we just gotta send that mother. So we can do as write, and we want to write the stream to write to, which is going to be our socket stream, the buffer. So ASIO gives us a little function called buffer that basically turns any standard container you give it into a buffer. So we can just do buffer request, and that'll use that string that we created as the request. And I think that's it. That's all we need to do. So now all we have to do is read the response from the server. So now one thing about the response is we don't really know how big it's going to be. So how do we create like a string or a vector of char to hold that? And the answer is we can, so ASI gives you a nice little resizable buffer class. So let's go stream buff, ASIO stream buff, and we'll just call this one the receive buff. And it will automatically resize this as necessary. So I can go AS read. Now we want to read the header first, I guess. So let's do read until. So we'll read from our socket into the receive buff. You don't have to wrap it with the buffer call because it is already a compatible buffer. And we want to read until this double new line pattern. And that'll tell us where the end of the header is. So now let's output the header. You can create a stream object to read from that buffer. So that's std iStream. Just call that is, and that is going to be constructed with the pointer to the buffer. Open a new scope here, and we'll create a temporary little std string for header line. And we're going to do for while std get line from the iStream into the header line. We'll output those header lines into cout. So we receive the transmission into this dynamically sizable buffer. We create an iStream interface on it. We can read line by line and copy that out to cout. All right, let's see if this builds. Let's see if we can read the header from the server at least. There it is. We received the header. Status OK. Content type text plain. Charset UTF-8. All right. Content length is 1338 bytes. That's beautiful. So far, very smooth. We are communicating with the HTTP server at boost.org. All right, now we just have to receive the content of the file that we requested. Now we're going to do a little different approach here. Over here, we used the resizable receive buffer, and we just said we said read until you reach this, no matter how big, and just keep growing the buffer until you reach this termination. But in general, especially for like the page content, it could be very large. It could be megabytes. It could even be gigabytes potentially. So you don't want to just, grow your buffer unbounded. So what you want to do is maybe create a upper limit on your buffer and just break your read up into multiple passes. Read into the buffer until it's full, then process that, and then read some more. So if we supply a fixed sized buffer to as read free function here, it'll only read until the buffer is full, and then we can output that and we just keep going. I guess I see one flaw here. If we read less than the full size of the buffer, we're going to output some garbage at the end. We don't want to do that. So we use the return value of the read function in order to size the fixed buffer before we output it to cout. Now this should work fine. Nothing could possibly go wrong. All right, so here is the content, and it looks like the Boost license. Yeah, seems legit. Only problem here is we end with an exception, end of file. And also, we didn't print out the whole thing. We lost the last part of it. So there's a little wrinkle here, and this is a little quirk of Asio. I like a lot of things in Asio. You're going to see a lot of things I show you are very great. I'm not a big fan of this one. So this is a thing that I'm not the only one who's noticed this. They've put a little blurb in their documentation, which is like why EOF is an error, and they have their justifications. And it makes sense from a certain point of view. But from the point of view of me writing something that wants to read a whole file, it's a little annoying, not gonna lie. So this is gonna throw an exception. Normally we want to treat our exceptions like errors, but this exception is not an error. This is the expected. The exception is not the exception, it's the expectation, which is dumb. So there are a few ways we can do it. Normally what I would do is I would wrap the read function and I would filter out that particular non-error and throw if it's something other than end of file. But for right now, what we're going to do is we're going to use, let's add one more thing. Using Asio error is equal to boost system error code. Okay, so all these functions, by default, they throw an exception on error, and that's what we want. But for the reading, guys, what we're going to do for right now is we're going to go Asio error EC, and we're going to say this one, don't throw an exception. If there's an error, write it in here, because I'd rather just check this than do a try catch to filter out that one end of file thing. And what we're going to do is if there is an error and the error is not equal to end of file, that means there's a real error, in which case we're going to throw system error constructed with that error code. So here we throw everything that's not end of file, but if it is end of file, we just say, hey, that's what it is. And so we're going to move this Asio error outside of the while, and now we're going to loop while there is no error code in here. So if we hit end of file, it's going to set this to E of F. It will not throw. It will output as usual, but when it goes back to the loop, it's going to say, there's some kind of error in here, and we didn't throw it, so it must be end of file. So let's terminate our loop. We are done reading, and we can do transfer complete. And there you go. So there is the whole sequence to connect to the server, to transmit your request, and to get the response. And beautiful. We reach the end of the license. Nothing is truncated. Transfer complete. A beautiful, beautiful situation. Let's see if we could do like a different URL. So in our CLI options in here, let's look at, let's call it URL. That'll be a std string. URL to fetch. We'll just make it empty for default. That'll throw a big old error. That's fine. And then in here, instead of hard coding that, we are going to do, well, let's make a little shortcut for our opts like so. And then we can go opts. We're going to do star opts dot URL. So we load that, parse it, and then we can use it. We'll just put a random URL in here. Nothing suspicious. And let's see if it can connect. Can we get something from Wikipedia? Oh yeah, here we go. We got the whole shebang in here. And it's all a bunch of, you know, socks. It's a lot of HTML, right? Because this thing that we requested, it was a web page, it's not just a text file. So we're getting a lot of hypertext, we're getting some JavaScript in there, some CSS, all the good stuff. But yeah, there you have it. Here is our very minimal HTTPS client. And this is going to serve as the baseline for future comparisons. We're going to look at, okay, well, what are the downsides of doing this in a synchronous fashion? How can we do it asynchronously? What are the different methods of asynchronous and how do they stack up against each other? That's what we're going to be exploring in the next few videos. Until then, thanks for watching. Hope you enjoyed this video. If you did, please click the like button. Helps again. I don't know what I just said there. It helps a lot. And I will see you again with some more C++ ASIO.